In this paper, we are analyzing failure distributions for different components for large-scale HPC systems. So we're looking at the problem from a different perspective by analyzing each type of failure independently instead of looking at the whole errors at once. And we were able to do that because last year we developed here at NCSA a tool that extracts events that are generated by the system, so different event types. And we also had a lot of help from system administrators in identifying which type of failure affects which of the components. By merging all our work, we were able to see how different hardware and software components, for example, I don't know, memory, CPU or network, can experience different failure distributions. So what we discovered was that different events have different behaviors. So far, everybody was treating events in the same way, and we discovered that some events have a periodic behavior, some have like a noise behavior, and each of them should be analyzed separately. For example, we analyzed Mercury, that's an NCSA system. It generates hundreds of thousands of events per day. So we wanted to extract all the event types that the system can generate. This was a problem because each time a new system comes, the system administrator has to get familiar with the language of the system. And basically that's what we're doing. We're extracting everything that the system can say. And by having that, it's easier to identify which are failures, which are just information messages, and basically characterize the behavior of the system. With today's systems, they will experience so many failures that system administrators will need some help in identifying what caused the problem, and well, we want to even predict what will happen so that they can take proactive measurements before the node fails and it affects the application. Our work will impact a lot of research in fault tolerance areas that are related to HPC systems, and we have an example in our paper. We demonstrate how applications can tune their checkpointing strategies to deal with the uneven use of components.